What we'll do is bring some amazing panelists up onto the stage to really deep dive into some of the thinking that's going on currently and where we're going in the world. Now, whilst we're doing this, have a think of some questions that you have. And a little way through the discussion that will kick off, we'll start getting you to put your hands up and say, hey, you know, what about this question? What about this consideration? How should we be thinking about artificial intelligence in the future? So is everyone feeling ready? Feeling jazzed? Okay, that's great. Okay, to get things kicked off, I'd like to thank our friends at Wells Fargo and to introduce Eric Greene, who's a lead AI architect here at Wells Fargo. Eric, thank you. Eric, if you'd just like to come up and join us here. And what I'll do is I'll just introduce up our speakers. So, you know, we know that things are moving quickly. We know there's a number of things that we can take away from there that we're going to get into in just one second. But before we get into that, I'm going to bring some of the people up to the stage. The first person I'd like to bring up to the stage is Petros Zerfos, who works with IBM Research in the Next Generation Applications Group. Welcome, Petros. A round of applause for Petros. All the way from New York City, so we've got a diversity in this. And then finally, we've actually got, from Feedzai, we've got Pedro Bizarro, who's the Chief Science Officer as well. So welcome Pedro. Okay, so like you covered quite a broad range of subjects there, right, Eric? So when we start thinking, I did AI like 20 years ago. It's much more simple. You know, now we've actually got a convergence of different technologies, and AI's got so many much more applications today in everything here. Everything, it's like the image and speech revolution that's happening around us, context of like location and usage, the security implications about suddenly we've got access to all this information, we've got all these sensors, we've got all this data in your organization, but then people can try and get hold of that. Once your capability gets stronger, security has to get stronger too. And then these barriers as well. How do we get in? The silos of data we know have always been an issue for the last 50 years or so, right? Everything from like paper through, we're talking about the old world of databases, pain, months of loading, and now we're talking about 10 minutes being like old data, which kind of blows my mind, right? And then, the skills and the employee landscape, and we see so much of this being discussed today, right? And lots of considerations. I'd like to invite you to start thinking about some of these and some great questions. But really, where do we start? And I think we have to start with thinking about 2017 and where we are today. And what I'd like to do is just invite the panelists to sort of, where do you think we are? I mean, we've come a long way, and we know that we're on that upswing of artificial intelligence as an application that's going to change business. But just give us some thoughts about where you think we are, and let's discuss that a moment.
Well, I think we're at the height of the peak of the hype cycle right now. But I think it's still there's a lot of stuff. There's a lot of stuff in the future that's coming at us, and it's really early days for what we're trying to implement. It's like there's a lot of those barriers are still there. We're still trying to connect the pipes, understand the algorithms, understand how to use this stuff, and then integrate it into our applications. So, and in Wells Fargo, we have machine learning and AI experts, but they're sitting back in the business intelligence area. And connecting those people up to the application groups and getting those to work together to build something, that's a major goal we have for this year.
Right.
So where we are and where we're going, we're seeing, first of all, the peak of certain technologies in AI, such as deep learning. They require lots of data in order to be trained, typically very large infrastructures. They're cloud-based. Along though with all this resurgence in AI, we're seeing other techniques that are, for example, more effective when your data sets are smaller. On a personal level, for example, we see a resurgence over there. We see issues that have to do with the ethics of AI and the application of AI, in particular with respect to what data is fed into these models. If the data is biased, then the models are going to be biased, which means that the outcomes are going to be biased. So there's a whole lot of discussion that is going around that. Some other aspects of AI that are really important and are becoming very important is essentially the natural way of interacting with AIs. So you see the increased use of chatbots, the natural language processing being the central AI technique, where essentially the system is able to absorb and understand natural language in English and other languages, of course. As we're moving forward, essentially the aim is to start moving towards reasoning, which is one of the holy grails of AI. Not as much in the sense of general artificial intelligence, that's way far off, but at least with respect to more constrained domains, such as the financial services, you might be able to start essentially be able to reason about your data and start doing inferencing and multi-step type of computations, especially in the context of information that is lacking, right? Essentially, when your domain is not of unknown information, basically. So these are some kind of exciting areas that are opening up in AI and the applications of AI to financial services.
Hello, thank you for coming. So I see two great trends in AI. So first one is that AI is really not new. It's actually from the 50s. But now it's finally attainable and affordable. So that's really the very big difference that we have today. We have clients at Feedzai that they are not experts in AI. Actually, they are not even technology companies, and they are using AI almost like turning on the lights. It's just a service that it's there, and it's providing great results. So right now, that's the really big change, is that this is not just for the Googles and Amazons or the top research labs. This is available and affordable for basically any person, any company. With even these deep learning, more esoteric and modern things are already available on the cloud, on Amazon. You can rent these things very easily. That's the one major difference today, affordable and attainable. The second one is that we really see the convergence between the human intelligence and the machine intelligence. So the machine intelligence works almost like a superpower that augments what the human is doing. It allows the person to do much more, much faster. And the human intelligence is like the driver. So you see really this combination of the machine helping the person and the person helping the machine in creating this feedback loop of more work, better work, and faster.
Okay, so we're sort of this inflection point. We're just stepping into the new world where suddenly more and more people are actually starting to do this. I mean, in the implementations, everything from like Wells Fargo inside and what you're doing with IBM Research and what you're doing with Feedzai, what are the biggest things that you're learning today from the implementations of artificial intelligence? You know, and in terms of, you know, what are you learning that you can pass along to the people in the audience that can help them like sort of plan a little better?
So I can say that we are already feeling that there's an arms race going on. So the fraudsters are already employing artificial intelligence themselves. So, and we feel that we are starting a new chapter of you really need to have it because the other guys on the other side are using it already to be more clever in their attacks, to be more organized and decentralized. So that's something that we see and that we need to prepare already.
One of the interesting things that we're learning as we're going about applying AI into various domains, including, of course, in the financial services, financial regulation, management, so on and so forth, is actually two things. The fact that it requires a different also way of thinking with respect to interacting with AI systems. In many cases, these are not deterministic systems, they're probabilistic. They operate in a stochastic sense, so you cannot make completely absolute guarantees, right? And that takes some time to educate people and especially the users of AI. And as Pedro said, one of the things that needs to be kind of better communicated is that it's not AI in the sense of artificial intelligence as it is about augmenting intelligence, meaning acting as an advisor, as a helper to the human cognitive abilities, to essentially extend them and accelerate them, right? So it's not something threatening, but it's something that works in conjunction with humans. And so this is something that requires quite a bit of education for the users of AI. And that's very important, actually, for the adoption of the AI system.
I mean, Eric, just on that point as well, just to add that flavor, that it seems education's important in Wells Fargo and the way that you're approaching it. how have you balanced like the education, you know, not only of understanding the data more so you can make the right decisions to do training, but also the people like in the offices, you know, the people that are undertaking back office operations around, you know, making decisions?
I think that's really, that is a hard part, because it's a total paradigm shift to how you would normally develop an application. There's no rules. Like, you don't have, if you have use cases you did before or some kind of waterfall method, it's kind of hard to fit a trained model into that. And that's just on the product development side. You know, you go into QA, and then, you know, the platform people and the developers, it's all new stuff for them. So it's really, the approach I think we're taking is you bring in some experts, you have a lot of training. And there's resistance in large organizations to change, but you have to start somewhere. And some of our approach, we work, as I said, security, they're the leaders. They've been used to changes in rapid threat environments changing quickly, and they know they have to act quickly. So our initial POCs and projects are with security groups because they know how to move, and then it's kind of going outward from there. So you pick the people that want to work with you first and the low-hanging fruit, and I think security is a really good case to start with.
But how do you pick where to start? I mean, you've got all these proof of concepts.
The lowest hanging fruit.
So the things that save you the most money.
Yeah.
Or the things that like.
Or you're essential, like security.
Essential security as well. I mean, what do you see out there as well? Because like research, you're like in the lab, you're working out what's going on. Feedzai, you're out there, you're working with customers. What are the kinds of proofs of concepts, or what are the kinds of areas that you're working on to help companies like Wells Fargo, other banking organizations and payments organizations?
So we've been working in many different areas: transaction monitoring, account opening, account takeover, third-party fraud. So there's lots of different attacks that are going on, lots of different risk perspectives that are going on, and we've been working on all of these areas. I would say that in addition to, of course, starting with low-hanging fruit, sometimes we start where the data is better. So we've seen that, and this is, if you're preparing your organizations to deal with machine learning and artificial intelligence, probably the most critical part is the data. We start working with many companies that, of course, they are collecting data for as long as they are in business, but sometimes they are not as careful with data as they should, and maybe the quality is not so good. There are some fields that are missing. Could be zip codes, could be dates, could be addresses. And when we start building models, those things really hurt. So the better the data you have, the better models you're going to get. Also like to point out that there's a very good book about models. It's easy to read books called Weapons of Math Destruction. It's interesting. It talks about our own biases as designers of models, and our own biases as the data that we collect, and that if we start with biases, we end up with a biased model. And it really highlights something important, that as we are designing these systems, we can, by mistake, design bad systems. And for example, in banking, on account opening, you can, by mistake, design a model that is racist, or that it takes into account things that it should not take into account, and is going to hurt your clients and yourself. So in some situations, you need to not capture some data, and in some situations, you need to capture some data. And it's important to know the difference, and when designing your models, be aware of what data are you feeding the model, what do you want it to learn.
It's actually interesting. I came to a conference, the Real Machine Summit last October. I actually used a quote from Weapons of Math Destruction, and the author talks a little bit about that in there, that some systems took handwritten applications, and if handwriting was poor, it was a determiner of a less adequate education. It was a determiner of a higher risk profile. And that's the kind of bias. And that's the kind of bias that you can't actually have from a regularity perspective, right? Like if you're actually an advisor, you can't say, well, your handwriting's terrible, so you're a higher risk profile. Some people, like doctors, would just have terrible like risk profiles, right? But hand over to Petros. Like, you know, we're talking about this, and we're talking about the bias and whatever. Yeah, what are you guys doing, like thinking about in IBM research? Because you know you've got Watson, you've got all these platforms, and you've got a huge amount of access to businesses around the world that want to, you know, make the world better. But like, how do you work out that sort of, we're doing the groundwork, we're trying to keep this with as much integrity as possible, but how do you have the conversation about who's watching the people doing the work, as well as, you know, actually developing new ways of working with artificial intelligence?
So yeah, in my group in research, we're primarily technology driven, right? Being a technology research organization. So we're also trying to think of kind of the most challenging aspects, technology challenges with respect to AI and the type of data that they have to, that they're called to process. One of the areas that we're looking at is that of analyzing unstructured data, meaning text. A whole lot of data is actually in textual form, in particular in the financial industry. And one of the quite interesting aspects is essentially the development of AI advisors and assistants to help with regulatory management, meaning the analysis of regulatory documents, the identification of the obligations and the requirements that the financial institutions have to comply with, and consequently deciding the controls that need to be in place in order to satisfy these requirements so that the financial institutions operate in a compliant way according to the regulators in the various jurisdictions worldwide. This is a very interesting problem, even though someone that thinks about regulations doesn't really get excited about this. But from the AI point of view, and special techniques with respect to analyzing natural language, as I mentioned, and doing such kind of a classification of what is an obligation and what not, it presents some interesting challenges. There's all sorts of linguistic nuances that one has to take into account and train the system appropriately in order to be able to handle changes in language, especially as you go from one jurisdiction to another. US regulations tend to be much more prescriptive than the British ones that tend to be a little bit more descriptive, right, by example. So these are some kind of the interesting areas that we're looking at, primarily trying to push the envelope with respect to the AI technologies and what they're able to absorb and understand.
I mean, in developing software and then developing new research and then into the practical world of, you know, a living, breathing bank as well. What are you finding in terms of regulations and the discussions you're having? Are you sort of in your own sort of Wells Fargo world, or do you talk to a lot of other banks and what's happening there? Because oftentimes new technology defines new regulations and governments are trying to chase up behind. Yeah. So like, how are you finding that experience today?
Well, I mean, we haven't really hit that barrier. We're in the lab, so we don't hit that as much.
Right.
I'm aware of the legal and the compliance issues. When I worked on the architecture, compliance was always kind of one of the steps we have to do. So I'm thinking ahead of that, like what, and part of what we do is for security, we don't have that many issues around compliance. It's like if you're doing something to protect security, then you're pretty much okay in most cases. But you know, if I'm going to do something where I'm doing risk modeling or credit scoring, you know, all the red flags go off. Maybe we'll avoid that project for now because it brings all those issues into it. As I said, it's a low-hanging fruit first, and then you go for the more complicated things.
But we're going to be like these projects, these hard projects
coming up, right?
But the hard projects are where humans are implicated. Like humans, like, you know, when we talked backstage, you know, how much human do you have to have in the system? But how much human do you have to have in the system to ensure that when that system touches other humans, that it's got integrity, it doesn't lack bias and whatever. So, you know, we're pushing off maybe some of these projects to future, but pretty soon in the next year or so, I mean, we're already seeing this with bots and, you know, payment systems. Humans are integral to everything.
Well, right? Just in bots, you can have bias in bots. If you're training a bot on a huge corpus of text and there's bias in there, there's our, you know, the Microsoft example. You know. So there's still those issues you have to be aware of.
And Tay.ai, and this is when Microsoft unleashed its AI on the internet, and the internet taught it to be racist and sexist in like a day.
Yeah.
The trolls got hold of it, right? So there's something to know. But at the same time, you've got an amazing piece of Microsoft technology that's also in China that's actually learned from billions of conversations in China, and now it actually presents the weather on national television, right? So there's a spectrum here, right? But like, okay, I don't want to let go of this regulations thing, because oftentimes when we introduce these new systems and these new ways that predictive thinking and machine learning comes in, what should we be thinking of as banks and as research organizations and software? I think Pedro's got something to say here. What should we be doing and thinking about today?
I think that's a great question. So one thing that we are doing is we are doing what we call white box explanations. So white box explanations is, so the model makes a prediction, right? And as humans, we want to understand why. Why did you, the model, made that prediction? And it's really hard to explain that, because maybe the model considered 10,000 different variables, and you cannot possibly explain 10,000 different variables to anyone else. You'll be bored, pages and pages of explanations. So we have been working quite for some long time on how to simplify a model in a way that you can explain it to another one, to another person. So we analyze those thousands and thousands of variables that internally the model is using, and we select the top most important ones and the most likely to have affected the decision, and then we produce these in a form of rules that a person could understand. For example, we recommend you not to open this account to this person because we've seen that this same phone tried to open 4 accounts in the last 3 hours, for example, right? So you kind of transform lots of calculations that the model did internally into a single sentence that a person could understand. So that's one way to approach the regulation size of it, is because you kind of make the model less of a black box and you make it transparent. You can justify it. You can explain why it got to that conclusion.
But that transparency, like as models learn, and say from now until 5 years into the future, your model changes and ebbs and flows, there's potentially thousands of white box explanations over that history. So how do we manage that as well? Because someone comes back from a regulator's perspective and say, okay, you've now made this decision. It's like, well, here's 15 volumes of like wiki to start going through to see all of the explanations from day one through to day whatever, right? I mean, is that what's going to happen, or are you going to stick with like the one explanation and then there's going to be an evolution and that's going to evolve and regulators are going to know this?
Yeah. So the models are going to evolve and the explanations are going to evolve as well. And you need to store, and we're already storing. Every time that you make a decision, you produce a score. You also keep track of the explanations you would be giving for that specific score, for that specific transaction. So that you might want to be able to look it up and to use it for further explanation. So yes, you need to evolve the model and the explanations.
Right. Petros, what do you think on this?
Yeah, that's a very interesting question and a difficult one. What we've seen as we're conducting POCs was the following, that given the result from 2 models, one of which is more accurate than the other, the users oftentimes tend to prefer the one that was the most explainable, and typically that was the less accurate one. So there is definitely this kind of need in terms of having the models being interpretable, explainable. There was a word in Eric's slides, traceability, right? So, and this is actually a very active area of research, particularly for the models that tend to be very precise or exhibit very high performance in terms of accuracy, such as the deep learning models that are all the hype nowadays. How to make them, essentially, to convert them into a white box. And I fully agree that the explanations essentially should have to come along with the answer that the model gives and the confidence level that the model provides. Along with that, having said that, there's also other areas in AI that essentially try to derive the rules automatically, right? So once upon a time, you have like to code the rules manually. Now you can use, you can start with statistical techniques, start emerging the rules, and then have the rules being applied, and the rules are traceable, right? So in some sense, you start essentially introducing explainability into your model. So although all of these techniques are actively researched on, and the issue of interpretability or explainability is very, very important, particularly for highly regulated environments such as the financial services, for example.
Yeah.
I think, I mean, you all look at the other side too, is like humans are biased naturally. So actually you could look at AI as a way to solve biases that already exist. So I think that's a good application, is actually using AI to, get rid of some biases that we already have in some of our credit processes and other things. So,
Yeah,
and also the regulation areas like that, AI can actually help with discovering regulations and complying. There's a huge body of regulations it's hard to keep up with, so I think that's a good use case in the future.
I find it interesting that human preference around explanation, lack of bias is interesting. Up in Canada, I worked with a research organization called Intentions, and last year we found that 1/3 of people would rather be managed and hired by an unbiased computer than a human. And I think that that's a sort of a level of trust that's coming into this. But if we can explain how our system works, and we can explain what AI is doing, and we can say this data's got integrity, and we can talk to other people in the market and say we're all kind of following the same structure and the same rules. How do we convince people that the markets are going to be steady, that payments are going to be safe, that they actually trust these systems? Because ultimately we're going to remove humans from the equation somewhat. And I want to talk a little bit later on around the employment landscape as well, because this is going to fundamentally change how organizations work. I mean, how do we usher in the technology so that the end user feels confident as well? I mean, I'm not sure what you found in your journeys from Wells Fargo or whatever else.
I think people are comfortable if it's giving them service, if they feel there's value in it. If it's something creepy, of course they're going to not want to use it. But I mean, we use AI in almost every app we use today. There's AI involved in there, so I think people are pretty comfortable already with actually having systems look at their data and predict and give them better services. So it really depends on how you apply it in what situations. You have to be careful to not make it seem like a creepy experience.
One comment that I would like to make is that the aim is not to remove the humans. As a matter of fact, on the contrary, the humans are very much necessary to provide the necessary supervision, right? And to essentially leverage the cognitive assist, if you'd like, that the AI can produce. And AI is nothing more than in some sense, great evolution of all kind of calculations, right? At the beginning, you were just doing simple averages, and now you have all sorts of complicated deep neural networks, essentially modeling any sort of function on your data, right? But the human will always be in the loop, and at least the way we try to design our systems, or to do research actually in our systems, and as researchers view this endeavor, is through augmenting what the human capabilities already are. But the final decision rests always with the humans, not with any AI.
Yeah, sometimes they call it intelligence amplification.
That's right.
Right? Not AI, it's IA.
Augmented intelligence.
Yeah, augmented intelligence. It's super interesting.
So I think there are two perspectives here. One perspective is from the side of people that are designing the systems, the professionals designing the AI systems. And here, I really believe that there will always be humans in the loop, because you need to calibrate, fine-tune, and give feedback to the models. Otherwise, the models will just run wrong eventually. They can be almost perfect on day one, but eventually they will start to get a little bit worse day by day. And we measure this. We know that the models degrade, for example, 1% per month. So we know that they're going to degrade. So you'll always have some sort of feedback loop. Could be analysts looking at transactions and confirming it's fraud or not fraud. Could be the card holder confirming it's fraud or not fraud. It could be the merchant. There will be always some sort of human loop, even if it's just to correct it. Otherwise, eventually it will go wrong. And then there's the other perspective as a user of AI, as a consumer of AI. And here I think there's two things, and we talked about this briefly before. As a user, I don't mind having, for example, an AI system which is almost like godlike. It knows everything about me and about the world, for example. I don't mind a godlike AI system if it's diagnosing cancer, right? I really know this AI. I really want this AI system to know a lot about cancer, about my personal health, about other people with this form of health and age and so on. So I don't mind an AI system that knows really a lot. But I mind if I'm like browsing the supermarket and I have an AI system controlling the ads that is showing me and changing prices based on my preference, then it becomes creepy and too powerful for my liking, right? So there's always also that context of what we want to do with the system affects how powerful the system should be. In some situations, it becomes unfair, right? If I'm in a supermarket and I'm completely being manipulated in terms of pricing and ads, it becomes unfair. But if I'm in the doctor and he says, well, you need to be operated because of this and that, I want that system to be super, super good, godlike.
So yeah, permission-based. It's like permission-based marketing back in the day, right? I mean, it's interesting, that feedback loop, the degradation and all of this. But like thinking about all of this, I mean, the modern functioning, like, you know, banking payments organization in the finance industry, you know, what does that look like? Because it seems like, you know, people that train AI isn't a normal job title today. People that think about ethics and bias in artificial intelligence and data isn't necessarily a function today. But, you know, people in the back office, people on the phones, people talking to clients in branches or whatever it is. So, I mean, where are we headed towards in terms of what that looks like in terms of, you know, the banks and the ecosystems? Because we're talking about this is going to give humans a great level of ability. But that changes, it changes the employment landscape entirely, right?
Yes, that's also a great question. So, as you know, there's no universities that are teaching fraud detection. There's no degree in fraud detection, right? And so what we do, Feedzai, is hiring. So we hire people for so many different backgrounds. We hire bioengineers, we hire electrical engineers, we hire chemical engineers, we're hiring people from all sorts of different backgrounds. And basically what we are looking for is people that are data-driven, smart, engaging, that are willing to look at the data and not make decisions based on bias. But basically anyone that has these qualities can be a good data scientist. So I think actually it's not limiting the type of people that can work, it's actually open up to more types of people, right? So today we have bioengineers working in banking doing fraud detection because it's opening up also opportunities to other types of people and jobs.
Super interesting. Eric, what do you find here? Like, as you're building out the labs are all about evolution and innovation and R&D and thinking differently. Are you finding this diversity is helping drive you forward as well?
Yeah, I mean, you have to look for people who can do, as you said, it's not just, there's no data science degree that just came out a couple of years ago, so you have to find people who have good math, I mean, to fill those roles. I think also an interesting point you mentioned was there's not necessarily a bias expert, or there's all these different roles that you just mentioned that will actually, they're coming about now, and those will be real jobs. So maybe there won't be as many tellers, but there'll be people in the background that will be training the models and doing all those pieces around that, right?
Yeah.
So I think that's how I see that developing out, and it's going to be a very different world, I think.
Yeah, and with you, Petros, what are you saying? Like, you're sitting there and thinking about, you know, everything with your team and IBM research. Do you think about the people that will be using the technology?
Of course. As we're doing POCs, for example, or we're testing out and thinking our technology, you always take into account the input both of the end users. Sometimes you also do co-design with them, as well as subject matter experts. They're essentially the ones that have the real domain knowledge, right, that you're trying in some way to capture. And what I've seen personally is that the most interesting outcomes typically come from multidisciplinary teams, where they don't just consist just purely from by computer scientists or statisticians, but with people with varying backgrounds, as Pedro and Eric said, that essentially provide different aspects of the knowledge around the particular system, around the particular problem that you're trying to solve through the introduction of AI technologies.
I mean, we've covered a lot of ground. Are there some questions in the audience? Yes, sir. Please speak up as well.
So, two questions, I guess. The last one first. Whatever happened to genetic algorithms that you see the potential for resurgence there? First question is, at Wells Fargo, how long do you think it will take before, say, half of your loan applications are processed by AI and not by a human applying rules?
I'm afraid to put a number on that, but I think it's pretty far off. I mean, just from the regulatory regime is not there to do that. So I would think there'd be more augmentation, as we've mentioned. There'll be tools that will assist people. Maybe, as opposed to saying we'll use it to deny people, maybe we'll use it to find more people we can give loans to, right? So it's an augmentation in a way. But I think the existing process and the regulation around that's not going to go away anytime soon. So.
It's kind of interesting thinking about that as well. There was a recent study that found that millennials would rather go to their dentist than a bank, right? And they'd rather trust applications from these big companies like Google and Facebook and whatever to do their banking. So one of the things is like, how quickly would it be within an existing bank? Well, actually, existing banks kind of know how hard it is. Whereas some kids building a new banking solution that can suddenly recruit like 500,000 users, that might be the modus operandi that they have from day one as well, right? But there might be the headaches. And this is why you actually find a lot of fintech companies that are starting to do that, working with established banks as well, because suddenly they hit a brick wall as well, right?
And it's a brick wall of just regulation and compliance.
Yeah, the brick wall of regulation and compliance, absolutely.
That's a very big barrier.
It's a really great question. Another question just there.
To leverage that question, so if you subtract regulations from the picture for a moment, what is your capability today to process those mortgages without a human interaction? Which level of confidence?
I think with the amount of data, we could build very accurate models. Again, as it gets down to how those models, it's going to be a very complicated model we might not understand, but it'd be very accurate. So that gets back to that question. If you want something that's traceable, that's a lot harder to do and have better accuracy. Yeah. But we have a lot of data on people, so we could do that.
I mean, how are you two guys feeling like the accuracy and capability is today? I mean, high volume processing, like fraud needs that, research and development, working out that high level of certainty before you let it loose into the real world, even in proof of concept, right?
So the level of accuracy typically depends on the type of application that you're dealing with, right, and the type of the domain. In certain domains, it's that are much more established. For example, the image recognition that Eric showed, or speech recognition, you already have pre-existing systems, so in some sense you start essentially improving by using new techniques or combination of older techniques, right? In certain other areas where you don't have pre-existing systems, that are a little bit more greenfield, then you start essentially asking the end users, right, what would you think would be an acceptable level of accuracy, meaning compared to a human, what would you think that the system would need to perform in order to be useful? Even more interestingly enough, there are certain areas where, for example, you don't have the absolute truth, and then in that case, you have multiple humans that cannot even agree amongst themselves about what the answer should be, right? So much more a system itself, right? This is the well-known problem. It's called inter-annotator agreement in more kind of technical terms. So essentially you try to build a system where it approximates as much as possible the consensus result that a group of humans would come up with, right? So I would say that's domain specific, right? In areas that are well established, you essentially try to beat pre-existing systems. There are certain others, cognitive regulation management, for example, which is an area that I have personally looked at quite a bit. You can achieve certain levels of accuracy that start becoming useful to the human that is going to be using it, whether that is a legal officer, compliance officer, so on and so forth. So it depends.
Yeah.
I also want to answer your previous question about genetic algorithms. Didn't forget about that one. Honestly, I think there's still room for genetic algorithms, and but they are used more and more just in optimizing parameters. So normally you run some sort of model with some maybe more generic parameters, and you find a solution, and then you use genetic algorithms to optimize around that solution. But many times they are also not used just because they are sometimes slower or harder to direct. There's still room, but I think it's less so than, for example, a decade ago. As for the other question about accuracy, we clearly see that machine learning is doing, in many cases, already much better job than humans, even for things as complex as credit allocation. We actually have a current client where we measure the mistakes done by the machine learning algorithm and by the humans, and the humans using 20 times less data, 20 times less applications, are making almost 2 times more mistakes than the machine. So the difference is enormous. So if you have enough data, enough history, you can really tune a model to be very, very accurate. Of course, you still need the humans in the loop to correct mistakes. Mistakes will still be there. But the accuracy is, with enough data, you will get to human-like, or at least consensus-like results. And it's likely that the model will be better than any single human. Maybe not better than 20 humans, but it's likely that it will be better than any single human.
It's like humans are the strong point and the weak point in the system, right? Absolutely. I think we've got a couple more questions down there. How are we doing for time then, Maggie? We good for time? Yeah, okay.
So you talked about the hackers using AI techniques. Can you elaborate on any two instances where it happened? Because I couldn't easily find that. I've seen like people are getting smarter about the beating system, but not actually using an algorithm from their side.
So yes, they are already using. We've seen them experimenting with different amounts automatically, different merchants automatically. So you have a card. What should you try? Imagine that you're the fraudster, right? The fraudster is trying to monetize that stolen card as fast as possible. They will try automatically different sites, different amounts, different MCC codes, different dates, and deciding which things to try is also a mathematical problem, right? If they try too much, they are going to get discovered quickly. So the amount that they are trying, and you see what we call the descending amounts pattern or the increasing amount pattern. So they are trying to check different patterns. Sometimes have to do with the amount, sometimes have to do with the velocity, sometimes have to do with geography. So we have seen more and more coordination of attacks. Sometimes things happening in the same minute in two places at the same time, coordinated to some time of day issue. So I think the level of coordination and the use of machine learning is increasing also on the other side.
I've seen that, but that's like not actually they're building a model and the output of the model is trying like binary search on what are the amount of right. But have you seen a use case where they actually build a machine learning model that attacks on machine learning?
Is there maybe like is there one particular like case study that people talk about today, or are they still random and very small and dotted around that it's difficult to say this person did this with this sort of thing, right?
So we, of course, I don't have a smoking gun. That's it. I was able to catch this guy using this model because they are hidden somewhere doing attacks online. But we do see things that are strange and that they don't look human-like. Actually, it was just mentioned last week that there was an attack, for example, on a voting site to make one city the top destination city. That we found out that the fraudster, actually the guy reported that on GitHub, the fraudster was using machine learning to mimic the time that people do while browsing websites, because he was trying to mimic a human actually doing the clicking of going through the website to proceed and vote on a city, right? So actually, if you describe that, that's the only instance that I know that the person really confessed using some sort of machine learning techniques to emulate a person. But I can see that if they are doing that for something as non-interesting as voting on the destination city for a competition for tourism, I'm sure that they are doing that for account opening, for example, right? Because they would be much more motivated to doing that.
Have you guys come across anything as well as you're developing? Have you come across that, or have you created use cases that you're trying to fight, especially in security?
I haven't seen actual examples on I'm not in the security group, but some of the projects I'm working on, like for IP blocking, the whole thing we're trying to do is to detect a pattern that's basically a bot network, and it's like something very automatic that's happening. So I can easily see them trying to train a machine learning model that would actually make their patterns look more human-like, and that basically would get around our system. So we have to have more complex recognition of those as well. So it's basically an arms race that's going to be going on.
Yeah, no, I agree. This is the hiding in plain sight, right? Yeah. Essentially, you try to present yourself as being the normal case. Yeah. Which is essentially pattern analysis type of problem.
Okay, I want to move on from that particular area. Are you?
I had the question.
Yeah.
Which was could you talk a little bit about how you can unlearn this induced bias into the system now that I'm on the cybersecurity side.
Sure.
As the cyber attack, yes, I have seen the scripts, and yes, I know how they work. So there you are. They do exist. Now, the thing is, they are introduced into the system. How do I unlearn them out of the system so that my system is less biased about what the norm really is? Share your thoughts on it. Sure.
So the AI unlearning what it's learned before, so it can then not have the bias, so it can like maybe relearn something and then eventually be biased and unlearn that. Yeah, so it's like Inception, right?
So that's actually a common and old problem. One side of it, it's called reject inference. For example, when you are ignoring, for example, because you're rejecting applications, so you end up not seeing those applications, so you don't know if they will turn out to be good or bad.
The
right?
99% false positive,
exactly.
But you've got your positive in there.
Yeah, exactly. So that problem is called reject inference. So because you're rejecting, you are inferring, you're assuming something about whatever you rejected, but you're not sure, you're inferring something. So there's many mathematical models to deal with reject inference, but the best one really is to let a small percentage of those things that you're going to reject to go through anyway. Because you need to learn that. Even though you thought it was a bad candidate, a bad application, a bad transaction, you must, as you're saying, learn. You must double check. So you need to insert the feedback loop into the system on purpose. That, of course, sometimes has a cost, right? You're saying, well, this is fraud, but let's see anyway. So there's a cost because maybe likely it was fraud. But the cost of not learning or unlearning in this case, it's probably higher. So you need to let it go anyway. And the other technique is to just retrain the model periodically, right? And your humans in the loop, the other ones designing the system and looking to the variables, sometimes they will discover that causation and correlation are different. Maybe the model was inferring some spurious correlation that made no sense. So I'm going to train a new model without that variable. So dealing with reject inference and doing model retraining are the two most common techniques to deal with that.
Yeah, it's a really great question. I saw someone ask, sorry, did you want to just add something there, Petros? Sorry.
Yeah, just to kind of follow up on what Pedro said, retraining the models is one very common technique. And one also has to be careful in terms of what data it feeds to the model. The model is only as good as the data that it ingests, right? So in some sense, once you try to build a model, you also try to make sure that your data is of high quality, as Pedro alluded to a little bit earlier, and that it essentially represents to a reasonable degree the so-called normal case. So you'll be able to essentially detect the aberrant behaviors, right, the abnormal behaviors. Retraining is definitely something that is needed. There are also other techniques, for example, from the statistical time series domain, which is an example of machine learning. where you essentially try to do the so-called regime change detection, where you essentially try to see whether your model applies into the current state of affairs, or just your worldview has changed, which means that you have to retrain, right? But yeah, retraining is definitely a good part.
Anything to add on this, Eric, at this point? Okay, great. Right, I'm going to look to over here. We're going to be around afterwards to say hi to as well. So there was a question. I saw you put your hand up over there. Speak loudly and tell us what your question is, please.
Hi there. I'm very interested in the question on how you store model versions or keep old versions of models for audit purposes and for these sorts of things. So it seems to me that's a real challenge for a lot of us in data science.
So auditable versions of models and data management and how you keep that traceability going forward, right? Who wants to attack that first?
I can take a stab at that.
Yeah, there you go.
That's actually a very good question and a very important one. It depends in some sense on the system that you're using and the type of models that you're developing. For example, for the more technically inclined here, there's a language which is called PMML, which is a language that describes machine learning models, right? And you can keep a versioning aspect through it. Also, it's worth keeping in mind that the model essentially consists of the algorithm itself that was used, along with the training set data that was used to train it, right? So it's a good practice also to keep a version of these as well, right? So that you know what you're referring to. There are other techniques also that can be used in terms of like serializing any type of data object, if you like, depending on the language that you used in order to build your models, and just storing them and persisting them into some persistent storage, whether that is a database or disk or something. So it's either through the markup language that supports the versioning or through the serialization, but always keep in mind what data you used in order to do the training, right?
Yep, I agree with both. Maybe I'll add just one more detail. Besides the data and the model, normally also store the model parameters. So because you need to be able to retrain it exactly as it was, and even the random seeds if you are using seeds. The filters that sometimes you apply just for national transactions or just for foreign transactions. So everything that was used to train the model to affect the results, you need to store it. At some point, you very likely are going to also get rid of old models, just for storage space. So you need to have a policy for how long you need to keep those models, because storing a model, as Petros was saying, involves storing lots of other things. So it's a model, it's a data set. The data set itself could be terabytes of data. You also need to store the schema associated with the data set, because if you want to retrain it later on, you need to also keep the schema. So all of those things can start to add up quite a lot, because it's frequent that in a fast-pacing environment, you are retraining models very frequently. We have clients where we are retraining models and putting models in production every 2 weeks. So it will be like 25 models per year. So it's a lot of information to keep track of. But you can have a policy that says, I'm going to keep models for 2 years or 5 years. So you need to just plan accordingly.
Yeah. And it needs to be in line with whatever the country denotes to be the amount of time that you can keep data as well, like Germany and Europe.
Yeah.
I've dealt with that a lot, and a number of other countries as well. It's very restrictive in terms of how much data. So that still comes down into the management as well.
Yeah.
Anything?
I think it's just really tied to your data governance strategy. So if you have data that's, you have to get out of the system at a certain amount of time, those models that are tied to it have to be out of the system as well. And you keep track of the models just as you keep track of code and all the parameters around it.
Yeah. Yeah.
So.
Okay, I think we've got time for one more question. Okay, you leapt up there.
Thank you. Eric, I saw on your deck previously you were talking about robotics. So wanted to know at Wells, are we looking at combining solution of robotic automation and cognitive computing, combining both solutions and giving an automated AI solution for like back office operations?
So I think.
So I just want to repeat that. So cognitive computing, robotic automation, and how that relates into back office operations. Yes,
Yeah.
perfect.
Yeah. So I actually was talking about bots as far as like chat bots, but we are. I mean, we in our labs we do look at like as a greeter bot, but as far as back office operations, I haven't seen anything on the horizon yet. That's pretty advanced, I think, for us. And you look at like, ATM is basically a bot, right? It's doing cash loading, it's doing all this stuff that's automated. So that probably would advance more. But I was talking more about like conversational bots as opposed to robots. Yeah. I actually have a robot on my desk in the middle of a building right now. It's just kind of a side project.
Yeah. Right. Okay. One more final question. Who's going to take it? Okay, down the front. There you go, sir.
Can you define machine learning, AI, and deep learning, or are they used interchangeably? What is the difference? Is there a technical difference?
I'll take a shot at it. I mean, I've heard it's really kind of mixed up, but in my mind, AI is sort of the broader category. And then machine learning and deep learning fall under that as different techniques. Deep learning is basically using neural networks. Machine learning is sort of the statistical techniques that's been around for a longer time. And AI is sort of the whole caboodle. And a lot of people, it's not like, when they say AI, I think it's very limited what we have today. It's like kind of a question and answer. It's not something that's super intelligent. It's something you train to do one thing really well. And then there's more advanced AI is coming in the future.
Yeah, that's a pretty accurate way of describing it. AI is the broader concept that encompasses machine learning, which is essentially the use of statistical analysis, typically on very large data, as opposed to very few samples. But essentially, it's a statistically driven technique, set of techniques to do inference, to do pattern recognition, right, and pattern analysis. Deep learning is the even more specialized technique within machine learning that essentially pertains to the use of neural networks that typically consist of multiple layers, right? So as opposed to the kind of older type of neural networks that consisted of at most 3 layers, back in the 90s or 80s, I should be saying, deep neural networks consist of multiple layers that are able to progressively model more and more abstract features from whatever input data you give them. So you start, for example, from pixels in an image, and through the use of successive layers in deep learning models, you're able to model lines and, for example, faces and a nose and eyes, so on and so forth. So AI is a broader kind of concept and encompasses natural language processing, symbolic representation, knowledge representation, reasoning techniques, probabilistic models, rules engines, ML, of course, machine learning, all sorts of stuff.
What is the excitement about Alexa? I don't get it. What's so exciting? I bought it, I used it for 2 days.
You want to?
Do you want
I don't know if I want to take that one.
Of the excitement around Alexa, we're talking Amazon's voice recognition technology. Imagine if you could ambiently just capture the mood and conversation in the house and then mine that data to be able to give you exactly what you want wherever you go. And then imagine, say, you create a store like Amazon Go that you walk into, and then it actually takes a picture of your face and your emotion when you pick up certain objects, and you can build all of these dimensions of who you are. And then imagine the value of that, and then imagine exploiting that. But it's just in the corner. It doesn't seem like it's doing very much. The ecosystem of Amazon is going to turn it into $1 trillion company within 10 years. The value might not be apparent to you. The value's all on the side of Amazon collecting the data, which is the shocker, right? And like some of these companies are actually harvesting the data to create this competitive advantage. But you know what, there might be a point. I've got a friend. We ask it to tell us jokes. It tells us bad jokes. It sings country and western. It's kind of fun. Ask it some silly questions. But then on occasion, you can connect that to the Internet of Things in your home, and it can turn lights on and off and control pretty much every device that's connected to the Internet, right? What's the value? I guess you're going to find that out as you go along. But I think you'll find, as you connect it with all the other Amazon parts of the ecosystem, you're going to find it to be very telling, the role of what that is in your life.
From the AI perspective, experts, like, is it doing something that's unique and very new, which was challenging before? Or
I think, as I said, the natural language processing is getting really good, and it's still not that great an experience. I think on it, it's very slow. It takes a while to communicate. It's not like a conversation, so there's still room for improvement. But looking at the curve, how things are going, I think it's going to improve really rapidly. And it is. I mean, it is a huge data boon.
And
sorry.
so image and camera is everything. Or enhance that with audio, and then enhance that with behavior, and then suddenly you've got an AI ecosystem that's going to be incredibly, incredibly powerful. And this is why data is going to grow by tenfold from 4.4 zettabytes today to 44 zettabytes by 2020. And because all the cars in the world are going to be creating an image of the world mixed to data and banking and payments and everything, and within these e-commerce systems as well. And the world's going to seem a lot easier and a lot less friction in what we're doing. And we're not going to even look at our phones in the future. Augmented reality's coming in and all these. I think it's a really interesting question. I think it's a hugely broad discussion, probably something we can probably do in another panel as well. I think we've reached the end of the discussion. I'm sorry, like if there's a question, come up to us afterwards and we'll have a chat to you as well. Thank you. I'm just really aware of the time. Thank you very much for your contribution here. I'd like to say thank you to Eric, to Petros, and to Pedro from the associated companies. Just want to remind you, this is their personal opinions. Okay. And I'd also like to thank Wells Fargo for hosting us here. Also BayPay for letting us come and run this event here. Thank you, Danielle. And also to Feedzai as well. And thanks to all of you being here. We're going to be up at the front. Come and have a chat. And have a great evening. Thank you very much.